Hi everyone, welcome to the session you see on the screen, Git Branching Moving to Recommended Model. For those of you lucky enough to be at GSE last November, um, uh, Ian did a fabulous presentation on Git Branching. It's always the first question I think that needs to be answered if anyone's thinking about going to Git. And it was such a well-received session that we thought we'd ask for episode 2. So this is what you're going to get. I'm going to hand over to Ian and Dennis, go on mute and take my video off. Take it away, gentlemen.
Well, thanks, Stuart. Yeah, thanks for joining. As Stuart mentioned, we did do this in the face-to-face. That was me flying solo on that occasion. Dennis couldn't join us face-to-face. So we had the theory of the branching scheme, a little bit of practice because I was describing workflows, etc., etc. But we weren't able to do the nice, exciting demo. So without without further ado, we've got slightly more to go through in this session today, and it was a very enjoyable session that we did face to face, and as is my reputation, we surprisingly overran, which we're going to try and avoid doing today. So I'm going to press on. So the agenda, kind of like last time, as Stuart said, the context for the branching scheme discussion is really important. And Dennis and Mathieu is in brackets there because he's another major contributor to this whole thing, but again, isn't able to join us. So Dennis and I are covering all this. And Dennis does this sort of far more real than I do with clients. I do it real with a lot of the teams inside IBM who have moved the source code for things like Kix, ZOS itself to Git repos. We use GitHub Enterprise, but I mean, Git's Git. So whether you're using GitHub or Azure DevOps or GitLab, or basically a lot of these principles still apply. Now we do have some aims and assumptions of what we're looking for in our branching model and in our recommended model. So we'll go through those. And then we'll get to the meat for about 15 minutes, I guess, talking about the fundamentals of the branching strategy. It's likely I'm going to have to cut the supporting workflows a little short to give Dennis the time required to actually show you some of the pipeline that supports these workflows in action, which I think is a really important thing. Obviously, all these charts are going to be available for you to look at, and I'll show you how I've handled that at the end. So, setting the context. As I've said, DevOps kind of is foundational to modernization. And the fundamental piece of DevOps for lots of things is, where am I keeping my source code? How am I managing my source code? And what are the workflows? What am I going to ask developers to do? What am I going to ask testers to do? How am I going to build? How am I going to deploy? All of those things. And they are all affected by the branching scheme in your GitHub repo that you choose. And as we'll see, there are many choices, but we make a very strong recommendation. Now, this is from learning what works, both internally in IBM with very large projects, very large, very small projects, in fact, actually, a wide variety of projects. And Dennis has done, and the DevOps acceleration team have done the same thing in many, many client situations as well. Now, something that I've been focusing on for the last couple of years is to try and turn this from being a voyage of adventure and being seen as very risky into something that's, well, nicely mapped out. And I'm sure you'll have conversations with lots of people with different opinions about how adventurous all this is, but it's becoming more and more mainstream and something that if you haven't started the journey, you should be considering. Now, one fundamental thing here is that the opportunity here is to pick the right tool for the job. So whereas we might be moving from an environment where there's one way and it's all integrated and it's all sort of done in the way you've done for the last 20, 30 years, we do have the opportunity to pick the right tool for the job. And part of this discussion is, yes, we have a guide. Part of a lot of this material is derived out of what we have as a Z DevOps guide, which you can find. It's out there on the internet. And funnily enough, it's hosted in GitHub. So we are using a lot of that. We are just practicing this all the time. But one of the things that GitHub is very good at letting you do is evolve stuff over time. And here's a little sneak peek of something we hope to update the guide to look like within the next few weeks. And so this whole experience of where you can go to look at this recommended model should hopefully be changing very shortly. And what we're experimenting with here is a whole journey view through evaluating what the opportunities are, learning what the goals and opportunities are and the new concepts, how you'd plan your journey, how you'd transform, do the journey, and then how, when you're in the new world of modern DevOps, use it. And then really the journey, you can complete phase one. There's plenty more to do. So how you would then go and iterate and continue your journey. So that's just a sneak peek at our new guide. So a really important and major part of the guide is to have this very discussion that we're having, which is what is the right Git branching model for mainframe development? Because there are many, many discussions from many different people with many different opinions about how you can use the very flexible facilities with Git to choose how you arrange that developers will change their code, test their code, submit their code for approval, move a pull request through a series of testing stages, how they get everything signed off, and how you would deploy. All of those activities are supported, for better or for worse, by the branching model. Now, we've seen lots of people make lots of choices about branching model. Probably the most nightmare I've seen is getting called up by a client who said, "We're in Git, everybody's committing to main, and it's chaos." And you say, well, of course it is. You didn't think about your branching model, did you? But that kind of is where we're aiming to help with our recommended model. Now, when I say there are many models out there, you don't just have to take our word for it in terms of this particular model, because actually, and to full disclosure, this is actually more or less precisely the one that is described on it happens to be the Microsoft Azure DevOps Services web pages about how Microsoft recommend that you do a branching scheme. Part of what we do in the guide is to orientate that towards where you're coming from in terms of a mainframe context. But the fundamentals are, we have main, and words are important. We have main as a long-running branch. We start every piece of work on a new branch, a feature branch. We aim to merge to main, and we recommend using release branches for when you decide to have a release candidate or a production deployment. So there's a little bit of life cycle and terminology comparison that it's just worth doing because, again, in my experience, we're talking to folks who are less familiar with this. The quicker we can start using the new language, the better. It's best not to hang on to we try to not hang on too much to the old world. We try to travel light and move quickly. But in terms of code storage, developer experience. We move from PDSs to what I might call a normal file system. Editing goes over to IDEs, so IDZ or VS Code. And we have branches as the versioning mechanism and commits. And that's the topic of the first half of this session. And then as far as processes goes and process implementations, we go from things that look a lot like JCL or actual JCL to automated pipeline scripts. And that's part of the demo that Dennis will be giving, is to look at how CI/CD pipelines support the branching model that we're recommending. And we have approvals through pull requests. We have deployments with a number of different tools. So, as I said, aims and assumptions. I've already mentioned that we like to get moving quickly. We like to travel light. We like to question all the old assumptions, just question them, not saying throw them away, but we question them to make sure that we're being optimized in what we choose that we need for the future. But aiming to be what I've termed Git native. So do everything with an eye to say, what's going to be recognizable to the outside world? What's going to be recognizable to new folks who are going to come to the platform? Are they going to recognize the way in which we work? Because that's one of the major opportunities that we have for adopting modern DevOps on the mainframe, is to make sure that the adoption by new people coming to the platform isn't frightening, isn't unfamiliar, doesn't make them run away screaming that they're never going to touch a green screen again, because perhaps they don't have to. And we start with this recommendation, as you can tell, fairly confidently. Traveling light, you aren't going to need it. YAGNI, that's just a little acronym to say, keep in mind that there could be things that you're doing today that you don't need to do tomorrow, because we are striving for simplicity. Our recommended model does and is proven to scale well. So that's scaling both down to small teams or infrequent changes on projects, or large and busy teams with many concurrent activities. So we think that this recommended model kind of fits for a lot of different scenarios. The life cycle here is really important. I've mentioned code changing, building, testing, deploying, but there is an aspect here about planning that we always need to mention. Planning to take advantage of new opportunities to do parallel development, for example. Branches and Git are built to do that. You can use it in a sort of simpler mode. That's part of the scaling. But really, we do need to have some Git native attitudes all the way from planning activities all the way through to deployment. So looking at smaller incremental deliverables, but we will talk about mechanisms to allow you to do larger pieces of work as well. So the nuts and bolts of the branching scheme. If you're familiar, I mean, I have kind of assumed here a little bit of familiarity that a branch is a way for you to create like a sand pit that is completely independent of what you might call what is called the main branch, and you can do kind of what you like in your own branch. The absolute claim to fame for Git is that branching is cheap. It is cheap in time, it is cheap in disk resources. You never want to worry about creating a branch. The only thing you do want to worry about is, if you have loads of them, how are you going to name them? And we'll have a little bit of a discussion about that in a few charts' time. But you don't develop on main, you don't directly commit to main, you create yourself a branch to work in. So developers work in the branch, and we should be able to build a branch, and we should be able to unit test a branch. Branches are not single commits. you'll get a series. So my personal habit is to have to use multiple commits to get a clean compile, as I'm sure most folks might be.
Me too, yeah.
So however many commits you might want to put on a branch, they all sit happily on your branch, private to whoever wants to see the branch. But we can build, test, and we use a branch and a pull request as the mechanism for reviewing the code changes. So we can build. We should be able to build any commit to any branch. We the commits, that these blobs on these lines here, signifying each commit, they are identified uniquely by what's called a commit hash, and they form points in the history of the code base. So it's really very obvious what you can see in terms of what's going on in the branches as the code changes over time. But we will assume that we can unit test the branches. When it comes to I've unit tested my feature or my fix or my whatever, the mechanism to then move that forward through its life cycle, through the life cycle to get it to where it needs to go, production probably, then all of the Git providers, Git service providers like Azure DevOps or GitHub, use a mechanism called a pull request. Now, pull requests are just a request to pull the contents of your feature branch into another branch. In this case, our branching strategy says main is the target that we want to aim for, but the pull request is the vehicle through which we would do reviews and approvals. We would have main as what's called a protected branch. So probably team leaders, release controllers, somebody with the right permissions would safeguard main and require that certain quality gates, tests, etc., had been demonstrated before they would accept the change into main. Now, at this point, I've said main and feature branches. We do not have branches that are named after the deployment targets, or rather the things we would have known in the old world as environments. So we do not have branches called production, because that's a deployment target. We'll explain just imminently what we mean by building and deploying to a production environment, but we don't have branches that match all of those, because all that means is you have to move the commits from one branch to another, cherry picking as it's known in Git native terminology, and that gets very complex and very risky, I would say error prone really quite quickly. Our serial history of the main branch is much easier to understand and supports all the workflows. One of the things Dennis and I have been recently working on is to do a straight comparison between environment terminology for branches and the recommended model. And there's kind of no, one of the surprises was that there was kind of little difference, but the difference is in what the terminology, the familiarity, and also the flexibility of what you then do.
And
So,
also around the workflows, Ian, right? So I think even if we would have environment branches, right, and it's more all of a sudden a manual step from the developer or a release engineer to kind of move changes from one to the other, right? So it causes a lot of extra work, which can actually be fully automated in the pipeline where we just say, okay, this is the candidate that we want to deploy, period, right?
yep.
And the
Yep.
pipeline does it for us.
Really good way of putting it, Dennis. Because when we come to how we organize this workflow, then main is the target for where all the code changes kind of want to get to. And when we have all the features complete, unit tested, we will decide on a periodic basis the cadence. You can decide for yourself, but we will tag and probably create what we call a release maintenance branch for a new release. We can treat this as a candidate. We can do candidate builds and we can do candidate deploys. And this is just the mechanism that says we can we can stabilize what we're going to declare as the next release, but still work and carry on with development work, even while we are proving the goodness of the state of the code that we want to deploy to production. So this can be packaged. We can have maybe even fix the release candidate. If we, shock horror, find a bug while testing the release candidate, we can use the release branch. We can commit to the release branch in order to fix the release candidate. And that's just a normal, familiar branching exercise, all under the control of the pipeline. So when we build and use this recommended model and we have the pipeline support for it, it all becomes very automated and really quite very Git native and very natural. But eventually our release candidate branch is good and we can build and deploy to production. Once in production, again, shock horror, you might have some bugs that you need to fix in production. And again, a hot fix will just be a branch that merges into the release maintenance branch. And that will be the specific sort of surgical fix that says, this is what I've deployed to production and this module needs to be fixed. Meanwhile, main is carrying on. Development is carrying on main, and then you just kind of repeat the process when you want to do your next release to production. So that's just explained the big picture of main, feature branches, release branches, and hot fixes. But we mentioned that scaling up is really important. Sometimes you might need to do quite a lot of work before merging to main and deploying to production. In which case, guess what? We use more branches. We've termed these epic branches. They can be called integration branches, but they basically are more of the same. So main is still the goal. Merging to main is still the overall goal, but you can use, here I've called epic for project one, is again a slightly longer lived branch, and it has its own feature branches from the epic, and those feature branches merge to the epic first, but you treat the epic branch as an integration point, and you can then decide when you want to merge the whole epic into main and use the same release process of a release candidate, test it, build it, approve it, deploy it. We mentioned earlier on the complications of, yes, branching is very easy, and so it's very easy to create them and it's very easy to lose control. But convention is our savior here, in that with a few rules around how you name these things, typically Jira IDs, ServiceNow IDs, work IDs, out of whatever is your work tool, can be the way in which we solve that. So all of the Git service providers will provide ways to query what's going on in terms of both branches and pull requests. But naming and tagging and those are the solutions to that scale. I did warn at the beginning that in order to give Dennis the time to do the demos, I'm maybe going to go fairly quickly through the workflows, and I've kind of described a lot of what goes on already, so I think that's why I can do this. But we have workflows in the charts that you can look at afterwards to look at how we do planned work, how we do fixes, how we do epics, and we look at it from the point of view of there's a whole workflow centered on the developer. So taking an item from the backlog, creating a feature branch, coding locally, IDEs, building what's in his branch, committing to the feature branch, and that feature branch can be built and tested, maybe certainly unit testing, maybe more automated testing, depending on how mature you are with that. And then create a pull request for review and approval. And then in order to keep sort of control here, the release control activities would be around merging approved branches, planning when you have your features merged and built and tested into a release candidate package, deploying the release candidate package to test environments. So off your release candidate branch that is named release and it's not named after the environment, and being able to fix that, then finalizing and releasing a package for deployment. So that's really the essence of the branching model discussion that we have. This is actually an industry standard model that we're applying to the mainframe. And now I think I'm going to we've got a couple of charts just to lead into Dennis taking over the screen share with an actual demo. So do you want to talk to this, Dennis, and I'll just flick the charts until you're ready?
Yeah, we can do that. So thanks, Ian. So we have about 10 minutes left, right, where we want to briefly walk you through about some samples, what our team, I'm on the DevOps Exploration team, work with customers. And obviously we've seen customers using different technologies, right? So the diagram, what we see here is really just a sample, how you can integrate the mainframe into your enterprise DevOps strategy. So there's obviously a pipeline orchestration service, as Ian mentioned. Is it now Jenkins? I'm going to showcase something with Azure DevOps in a moment. Is it GitLab, GitHub Actions? So all follow similar principles. On the right-hand side, we see that agent, and that agent obviously needs to trigger those pipeline actions and tasks on the mainframe to get access to the code that is now stored in Git, distributed, but also need to build it on the mainframe and even deploy it to the mainframe. So all those actions need to be performed on the host. And with all the rules and principles that we now described about our recommended workflow, we have put together a set of services that help you to really implement that model very easily and safeguard really those principles. If we move on, there's kind of, for instance, something very common, right? Ian said we can build any commit or we can build any branch here. And there's the need to have a unique high-level qualifier, its own data sets for the builds, right? And our services basically give you that computation. So it also allows you to run different build types, compile with the test options or compile with the optimize options, right? We have obviously different build life cycles. A feature branch pipeline might look a bit different to a release pipeline, where we actually create a release candidate, automatically tag the repository, produce a package that actually can go into towards production or in the more controlled and higher test environments. Also, our services really enforce a common strategy to store the packages in the binary repository. So we talked about Git as the repository for source, but there's also another repository which is all about the build outputs. Typically, this is Artifactory or Nexus, but we can use pretty much any repository that exists. We are now enforcing kind of a strategy and a layout of those repositories with our services to segregate those builds that are perceived more temporary, but also the other ones which are kind of true release candidates that can go to production. And some will go to production as well, right? So all this included in those services, and it's easy to consume for the user. So if we go on, I think I'm pretty much ready. What we will see in a moment is a pipeline for an application. It's not only about building, but obviously about packaging and also deploying to the various runtime environments. And those services and templates are two components that our team provides through an open source Git repository. So it's not only about the services that I described, but we also have pipeline templates out there that implement our recommended model from end to end. And we have those templates available for Azure DevOps, for GitLab, for GitHub Actions, and Jenkins. And we are in the process to continue continuously to enhance them, right, and make them simpler and even easier to adopt. Okay, so I'm going to take over the screen. Where is it? It worked fine at the beginning.
At the bottom, Dennis, there's a green arrow pointing up that says share on the bottom of Teams.
Zoom.
Sorry, Zoom. Thank you, Ian.
Yeah, it's my mistake because I think I did something wrong here.
It appears when I move my mouse over the window.
Yeah, that's exactly the point. Alrighty, so I think now we're done. About 10 minutes to go, right? We can take some questions at the end. This is our Azure DevOps environment. We have an organization, the IBM DAT team. That's the team I'm working for at IBM. And we maintain a set of applications and samples in there. So the Azure DevOps platform is really a DevOps platform that contains project planning, source control, and builds all in one, right? So in our repository, we have a set of files, right? It's a sample application, it's a COBOL Kix application, and all our source code is stored in here. And there's an entire history. And so I would like to point out a few things. So those conventions that we talked about, right? We have one branch that is long living, that is main, and that's the default branch. But any developer can only add changes onto or into main by raising a pull request. And I'm currently working on a new feature. That's why it's in that feature folder over here as well, to kind of propose changes for our next planned release. So I'm going to flip to VS Code. In VS Code, I'm actually connected to the mortgage application with our feature 16 compute release version, probably not the best name, but again, we see the same contents like on the website. So we have all our COBOL source, we have build logs that I can access, and build information as well. So this is the Open Editor. The Open Editor comes with a language server. It understands COBOL pretty well. I can navigate, but that should not be the main focus for today. Feel free to reach out. We also have kind of trials available that you can play with it. So when we talk about Git in here, I can easily check out the file history for the program that I just selected. And you see the entire history where we are right now. So this is on main. It hasn't changed on my actual branch, but I see the entire history from March this year into last year. You see all those tags in here. These are kind of release candidates that we had built and that are kind of in our system. I'm going to quickly show you one integration. So I'm going to close these two editors over here. This is the CPS CMRD module. Ian talked about the user build to check if everything builds successfully. So this, even that everything is locally on my machine here, we are interacting with the mainframe through the SOE Explorer and through the mainframe interfaces USMF, right? And I'm running a user build that uploads files and its dependencies. It has a lot of output in here. And finally, after 4 seconds, the build already completed successfully. I can access my compile listings just from here. And this was just kind of built a minute ago, right? So this is kind of how I can, as a developer, perform changes to the files in my application, in my project. I already have done a few, right? And I just would like to showcase one more thing in VS Code. Oops. There's something which is called the Git graph, and this might look familiar to what Ian walked you through in the model, right? So we have those conventions again. We see the entire history. We see the branch which we are on, so feature 16. We see where main is. We see all the commits that I already did, right? I updated a sample file. I did an git ignore and did some other configuration. That's where we are at the moment, right? So I can now drill into all those changes, into all the history, can compare things. What I already have done, I pushed this branch and these changes back into Azure DevOps. I'm switching over here, and we will take a look to the pull requests. So there are some changes that I'm proposing that should flow from my feature branch into main. So these are kind of all the updates that I did. These are the files that are involved. And I just dropped some code in here, right? And what I'm going to do, and theoretically, there should be rather a teammate. He's going to review and approve all those changes so that those changes can flow into the main branch. So let's approve my own, right? It's not the best thing. There are no good policies on that project. But then I can go ahead and also complete that. And when I complete that, this is now kind of taking all the commits from my feature branch that got approved by my teammate and merges them into main and make them part of my next release candidate. So I'm going to go ahead and say complete merge. So I had no merge conflicts, right? If there would be conflicts on files, then this would be, I would be told to fix them here. And what happens automatically in here is there will be a new pipeline being kicked off. So pipelines are what really is the magic of automation in here. I flip into the pipelines over here. We see all the branches that got built. We see the build history. Some failed, some were successful. As the same like Ian, I'm not always successful with my first changes, right? And I need to redo things. So I can just go into the history of main, and you see those reference merged PR 78 minor updates to demo workflow. So and now all those services start to execute. So on the setup, because the pipeline actually is executed by an agent on an x86 box, we then clone the repository to Unix system services. I can just go in here, clone application, and these are the services that I talked about, right? They kind of clone everything into a Unix system services directory, and there's a work directory for the ADO user with a workspace, and it's unique. And if we switch back, it continues to build, publish build logs, package, and finally even deploy it into a system, right? So we've got about 5 minutes, right? I can just go into build. So what is a build now, right? A build uses, in our case, dependency-based build. There's build configuration that is stored in configuration files, and the build will invoke the compilers, the linkage editors, and more specifically, it will automatically understand which files have changed for our next planned release. So the build is actually very smart. We track a build history, and we then understand with the changes that I did, that other developers did in the past, right? It builds up a cumulative package for our next planned release. And these are the files that got built. And after those 10 seconds, we even publish the build logs. So let me, go back in here. I move back to the pipeline overview. We automatically publish all the build logs. So there are the sysprints for COBOL compiler, from the COBOL compiler, from the linkage editor. So we can explore them in here as well. So once the pipeline and the build is successful, we kind of run a packaging step. And the packaging step now takes all the build outputs and stores them in Artifactory. So that took just 17 seconds. It detects kind of all the changes. There's a lot of data in here, but we are kind of moving these things and then upload that to our internal artifact repository. And I have it already in here. That's kind of the mortgage application. We have kind of the segregation into those more temporary pipelines. And we just merged into main, right? So this is kind of still a development build that we do before we create the release. But here we should have a new branch, a new output being produced automatically from today, right? And there are kind of conventions about the linking those packages back to the pipeline, back to the changes. So everything is traceable at the end as well. So this build or this pipeline already deployed the package into our shared development integration test system. Let's assume that we are now testing and the application team decides we would like to move on and go into the acceptance test environment and continue our testing there. I can just go back to my pipeline. And this is more a decision by the team, right? Oops, apologies. So we run another pipeline. And this is also in all our templates. We now, instead of running a build pipeline, which is more a development build pipeline, we select the pipeline type release. We can even say if it's a minor patch or major version, right? So by default, I pick the minor version because I'm not breaking any compatibility with other applications. I'm going to execute this run over here, and this will build a similar package, obviously, but now with the optimize options. It stores the package in Artifactory again, and it will now also tag our repository and mark those important commit hashes that we can trace back in our entire history. I'm going to switch to that one over here about the tags. I think we are currently working for release dash 1.5. Oops. Oops, what did I do? That was the wrong search. I put in the search string in here. So these were already release candidates that got produced. So obviously something got produced earlier this month, right? Our next planned release 150 is not in production yet. So that still takes some time. It's a demo system, but it's probably worth to push it to prod pretty soon. Alrighty, so that's kind of gives hopefully a bit of insight about those implementations and the templates that we have produced and that we published through the Git repository. There's additional collateral, right? We are very transparent. The Git branching model is in the ZDevOps guide. So I don't know if Ian, you already dropped the URL into the chat where you can access, excellent, where you can access the slides We have a couple of blogs, obviously, that we've written. This is the community repository, which contains all those templates. And we also put together a set of videos. If you look for IBM Z trial, there's an IDZ for VS Code trial, which actually walks you through the entire process of having feature branch pipelines, integrate into main, and create a new release. I think we are hitting the end of our session. Are there any questions?
We've been having a little chat about the temptation to keep or try to replicate the old world, which kind of is a fairly strong temptation. But I always for better or for worse, I always picture that as you're going to be halfway across the fence. It's always painful to sit halfway across a fence. And so, as I mentioned, both sort of becoming more familiar with the terminology of the new world very quickly, but also getting to kind of an MVP of the modernization journey as soon as possible is what we would recommend that you aim for. You have to say goodbye to the old world at some point, because otherwise we're just going to be perpetuating and missing out on the opportunities that the modern tooling presents. So there's an element of biting the bullet kind of going on here. But I mean, I mentioned earlier that Dennis and I and Matthew, in fact, were trying to specifically address the similarities and the contrasts, because people picture, sometimes it comes across that the new world is really radically different. And sometimes I think the new world is radically different. But then when you really compare, and this is the work that we might try and start delivering, if we compare the old world in terminology and workflow to the new world in terminology and workflow, it starts to be a lot less scary and a lot more, it's more more approachable. And we certainly recognize that's a need. So Dennis, I think we need to dust off that PR where we were adding the discussion about the environment branches versus no environment branches, and oh look, actually it's the same, and deliver that into the guide as soon as we can.
I think the workflow to have those environment branches is just the purpose to deploy changes into an environment, right? So that's what the user would like to accomplish here. And in here, it's just built into the pipeline to deploy the package into it. So there's no extra work to merge kind of changes to another branch or something, right? It's just the installation of the package into that corresponding environment. Here it's just pictures out the defint and acceptance, and we can put in approvals here as well. There could be another release pipeline as well, where people have more control over it, that's not all baked into one pipeline, and say, okay, developers can go up to environment X, but not into acceptance tests, pre-prod production, and I bet you might have more systems than our 3 systems in here.
Well, thank you, gentlemen. I think to just add, if you don't mind, leaning into the culture that probably already exists in the client, Ian, Dennis, you know, around the Git usage, it's been in use in the distributed world for many years. So leaning into their own branching strategies that they probably refined is the sharing of that culture as well, which perhaps softens that sitting on a particularly prickly fence. So thank you very much. I hope that this will continue this conversation into November at Whittlebury. You're very much less animated, Ian, on Zoom than you are in real life. There was a bit of hands waving. And if anyone does have any culture issues at their client, if they invite Ian along, he will correct people's thinking. Lovely.
Correct their thinking.
Thank you for the content, gentlemen. Thank you for the attendance. Really good numbers. So the recording will be available in a few weeks' time on Vimeo. So great stuff. Have a good day, everyone.
Thank you. Thanks,
Thank
everybody.
you.